I'm Richard RJ Eskow, and every time we talk about reining in the runaway, what I would characterize as the runaway greed of big pharma, we're told, well, it costs a lot of money to develop all these drugs they sell and bring it to market. Now, of course, we've covered on the show the fact that sometimes that money is borne by the American people, but they do, of course, develop research and develop drugs of their own. Our next guest looked into that topic. Dr. Vinay Prasad. Vinay Prasad, MD, is a hematologist oncologist. He is assistant professor of medicine in the Oregon Health and Sciences University, and he is also, by the way, I should mention, senior scholar in the Center for Healthcare Ethics, and he is the co-author of a new paper in the journal, in JAMA, the Journal of the American Medical Association, Research and Development Spending to Bring a Single Cancer Drug to Market and Revenues After Approval. It's very relevant to the conversation taking place now, so we asked him to join us. Dr. Prasad, thanks for coming on the program.
Thanks so much for having me.
So what was the impetus for doing this research, first of all?
Well, you kind of framed it nicely. I mean, I think many of us in society are concerned with the high and ever-growing cost of drugs, particularly cancer drugs that now cost routinely in excess of $100,000 for 1 year of medication. And over the years, we've tried to assess some of the arguments for why they have to cost so much. So one of those arguments was that cancer drugs cost so much because they work so well. Well, a couple of years ago, my colleague Sean Milancody and I, we actually kind of debunked that argument. We looked to see how well they work and how much they cost, and we found there was actually no relationship between the two. One of the other arguments you hear tossed around is they cost so much because they cost so much to develop. So here we wanted to test whether or not that was true. How much do these drugs cost in terms of R&D outlay by the firms that manufacture these drugs? And you should know that prior to our work, there had been one very prominent analysis that came from the Tufts Medical Group in Boston, and they said it was about $2.6 billion to bring a drug to market. But there were some challenges with this research. One of the things was they wouldn't tell you what companies they looked at, and they wouldn't tell you what drugs they looked at. The analysis was entirely secretive and non-transparent, and that's fundamentally antithetical to science. And so we wanted to pursue this question in a way where all the numbers would be publicly available to anyone who chose to check them.
Yeah, and I think, not only, I just want to say, not only is that kind of lack of transparency and antithetical to science, is antithetical to policy making in a democratic society. I think we deserve to know what we are paying for life-saving drugs. So as someone, hematologist, oncologist, so you conceivably have been in the position where patients' life and death could depend on their ability to spend $100,000 for, I just want to put this in context, their ability to spend $100,000 for a needed medication. The two economic arguments that are made. One is that's the market value because it's just so much better. Now, whether you even think market value should come into play in life and death matters, I don't. But that's the logic that's sometimes used. Well, that's the market value because this drug is just so good. It's just $100,000 worth of goodness in it. You've disproved that. Now we get to, well, it just costs that much to bring it to market. So, and of course you focused on cancer drugs, and for the reasons we've said. So you looked at Securities and Exchange Commission filings and so on, and what did you find?
So basically we found, and we picked a unique set of drugs where we could really kind of run a clean analysis. We picked 10 drug companies that didn't have any drugs on the US market. They had 43 drug compounds in clinical trials, and each of those companies was able to get one drug successfully to market. So that's a failure rate of about 77%, and that's kind of consistent with the failure rates in the biopharmaceutical industry. And what we found under these assumptions was that the cost to bring a drug to market was about $650 million, which is a lot lower than that Tufts number. And if you gave these manufacturers some credit that instead of using this money to invest in drugs, they could have used that money and invested in the stock market, for instance, and you gave them a 7% lost opportunity cost, well, then it comes to about $750 million for bringing one drug to market. And that is much smaller than the popular estimate from the Tufts Medical Group.
So here's what I got out of what you just said, Dr. Prasad. You talk about 7%. Other people, the Affordable Care Act, for example, sets profitability rates. Now, I think I've studied this. This can be gamed, but the policy objective was that from the Franken Amendment, I believe it was insurance companies should be able to get a 15% profit margin. You're looking at profit margins that are many multiples of that for producing cancer drugs. Isn't that right?
That's correct. I mean, one of the provisions of the Affordable Care Act is that insurers are capped in terms of what percent of profit of the amount of revenue they process that they're allowed to keep.
Right.
But that rule doesn't apply to pharmaceutical makers or device makers. And the profits in the biopharmaceutical industry have been tremendous. Our analysis sheds a little light on that. We found that the revenue after approval for these drugs, just to put it in context, it cost about $7 billion to bring 10 drugs to market. In the first 4 years of those drugs being on the market, these companies reaped about $67 billion, which is a tidy amount of money. And they have probably on average 10 more years of exclusivity left. So it's going to be a lot more money. So I guess I would say that it is clear financially the drug development business is highly lucrative for companies that bring drugs to market.
Well, it's a very, very important finding, and it really needs a lot of attention. My takeaway from it is, first of all, you'd almost, if you were just a heartless investor, you'd almost be crazy to invest in anything else nowadays, which is a horrible state of affairs. But secondly, the term gets thrown around political economy. The idea that money basically drives the political system. There's a relationship between what happens in the economy and politics, and these guys just must have my takeaway, and I know you didn't go this far in your research, but my takeaway is these guys must have the best lobbyists in the business.
Well, I guess that's my takeaway, too, from having studied this issue over the years in different publications. But, I mean, you have to look at this system. This is not a free market. I mean, cancer patients really don't have the freedom not to choose these medicines. These are often life-prolonging medications. The second thing is there are so many rules in the system that prevent public payers like Medicare from being able to say no to cancer drugs that work very poorly or being able to negotiate the price of these drugs. And so the result is a system where drug makers can literally charge whatever they wanted, and payers really have no downward pressure to say no or to negotiate the price. And this is fundamentally not a free market. It's already a market that has a whole bunch of interventions in the market that actually work against the interest of the average patient and the average American, frankly.
Well, or as my old boss Bernie Sanders used to say, the game is rigged. Now, I just want to ask you, and again, we're talking with Dr. Vinay Prasad about the paper he co-authored on the very high profit margins for cancer drug development and production and distribution. Were you surprised that the profits were this great?
I mean, I guess what surprised us about this paper was just that this was the R&D number. I mean, when you look at it in a very objective way, the R&D number to bring a drug to market is less than what had been advertised. It's not 2.6 billion. It's probably about $750 million, $750 million. In terms of the revenue that these companies generate, I guess I'm not surprised to know it's massive. I mean, it's massive because the price of these medications is massive. Just to give you one example, a couple weeks ago, we had the first ever CAR T, a new type of medication approved. The company is charging $475,000 for one dose of the medication. I mean, we're reaching heights of drug pricing that historically have been unheard of. And the price of cancer drugs is growing faster than almost anything I can think of in the economic sector.
$475,000 for one dose?
That's correct. That's for these CAR T, Chimera. And it's a medicine where one dose may be all you need, but that's a tremendous price for one dose. And there's a whole bunch of reasons why that price may be too high. And one of those reasons is something you alluded to, which is who shouldered the burden to bring that product to market. And in this case, the National Institutes of Health, in an analysis by a patient advocate named David Mitchell, The NIH has put in $200 million into the development of this type of product. And yet you still see it priced so high. So in many cases, a lot of innovation is actually driven by public sector funding. Now, that's not to say companies do nothing. They do a great deal, and they often shepherd these drugs to market. But we have to talk about how much profit is fair and reasonable to drive innovation, and how much is merely excess and profiteering. And our paper kind of puts that in perspective and suggests that perhaps much of these prices is actually just leading to profiteering and not true innovation.
So, to me, first of all, I agree with you. This is not a market, free market in any economically coherent sense of the word. People, first of all, people follow their doctor's recommendation. They don't go out and say, well, I like the blue pill better than the green pill or whatever. So that's number one. And number two, there's no competition, right? I mean, I can't say, well, I don't like, if my doctor says I'm supposed to take this form of CAR T treatment, I don't say, well, I kind of like the Acme CAR T treatment better, because there isn't such a thing. So they're not forced to compete on price. It feels more, when I hear a number like $475,000 for a single administration of a medication, that feels more like a ransom than a purchase price.
Yeah, let me just make one point about competition. You're right that for many types of drugs for cancer, there is no direct competitor. It's really that drug or nothing, or that drug or drugs known to be inferior. But there are a few places in cancer medicine where there are some competitor drugs. For instance, CML, there's imatinib, dasatinib, and nilotinib. There's a few drugs that work rather comparably. But let me tell you something about that. In these situations where they've been competitor medications, when all those medicines are branded, we haven't seen price come down as you'd expect in any functioning market. What we've seen is the price of all three have gone up hand in hand over the years. What you really have with pharmaceutical drugs is a fundamentally broken system, a system that really has very little downward pressure. And part of the reason why people have been scared to apply downward pressure is because of this persistent fear that if we did anything to this system, we would somehow halt or stop innovation, and we wouldn't want that. But what our analysis suggests is that it's unlikely we would stop or halt innovation. The R&D outlay for these 10 drugs was $7 billion, but they've already earned $67 billion on the back end. That suggests that there's room to lower the price and still have all of the R&D we currently have.
And again, that speaks to my analogy of a ransom, your money or your life kind of a threat that people are getting. So I guess I would just conclude, Dr. Prasad, by saying that CAR T is not just a cancer treatment, it's also the first four letters of cartel.
I guess what I'd say is there are really some fundamental structural problems in how we pay for and incentivize drugs. And the goal of regulation should be to bend these for-profit companies, which do offer value and do help shepherd these drugs to market, but to bend their interest closer to the interest of the public good and public health. And there have been a number of very successful policies that have been implemented, and many more policies that could be implemented if people took this very seriously. But the goal of all regulation, I think, is to bend the interest of others to the public good, and that's what we need here.
Absolutely. Well, I couldn't say it better if I tried. So Dr. Vinay Prasad, hematologist, oncologist, and co-author of this important new paper on cancer drug funding. Thanks for doing this important work, and thanks for coming on the program.
Thanks for having me.